Hello and welcome to Empowered Learning. This is the second video in the Polynomial Basics series. And in this video, what I want to do is go over some basic terms or basic names that we give polynomials depending upon how many terms are in it, as well as go over the basics of adding, subtracting, and multiplying polynomials, because this is a skill that we need to be able to do to work with polynomials functionally to do other things in mathematics. So let's go ahead and get started with the names of polynomials according to the number of terms they have. So a polynomial with just one term is called a monomial. And so a polynomial with two terms, can you guess what that is? All right, so if you said binomial, then you are correct. And so we know mono means one, bi means two, so a polynomial with three terms would be what? Yep, that's right. It would be trinomial. Okay, so we see here all of these just have one term. All of these have two terms. And all of these have three terms. And so again, every term looks like a power function. And if you don't remember what a power function is, you may want to look that up, or you can look at my part 1 video for this series where I go over that extensively. So just to make up an example of what would not be a monomial, binomial, or trinomial, let's say we had something like y equals 5x squared plus x plus square root of 3x. So in this case, this would not be considered to be a trinomial, only because this term has a square root in it, meaning that this is not a polynomial in the first place. Okay. Another example, let's say if we had 6x cubed minus 5 plus, let's say 2 raised to the x. So in this case, this is not a polynomial because we have this term here. We know that 2 raised to the x from watching the previous video that I've done for this, that would be considered an exponential expression, not a power function expression. Okay, so we know that a polynomial is the sum of a bunch of power functions, or functions that look like this, variable raised to a fixed number, where this particular number here would be a positive integer. So like 1, 2, 3, 4, 5, 6, something like that. Okay, or really I should say a whole number, because we could have 0 here as well. So n could be 0, 1, 2, 3, 4, 5, 6. So it doesn't have terms that look like this or can reduce to that, then it's not considered a polynomial. So this would not be a trinomial, only because this particular term is not allowed in polynomials to begin with. Okay. All right, so let's move on here. So now what we want to do is work on adding and subtracting polynomials. And so if you've gone over the concept of combining like terms whenever studying linear expressions or linear equations, then this will make sense to you. It's just that with polynomials, we have a lot more going on, so we have to make sure that we are a little bit more strict on ourselves whenever we try to combine like terms together. And so I like to say that we just put the apples with the apples, the oranges with the oranges, the pears with the pears. Okay. And so when we look at this, we may have a term that has x in it, x squared in it, x cubed in it. We may even see some stuff like, let's say, x cubed y squared, or x squared y raised to the 4th. So all of these expressions here are unlike terms. And so here, any term that does not have everything that you see here in it is not going to go with another term that has something different than it. So give you an example here. Let's say if I have this, and let's say I have 5x and say 4 here minus 3x. So in this case, I know that this term and this term are like terms because they both have x cubed y in it. And I know that this term and this term are like terms because both of them just have x in it. And you notice that we're comparing everything except for what the coefficient is. So if I look at this term and I say, all right, if I have 5 apples plus 4 apples, then altogether I have 9 apples. And here, if I let the terms with just x in it represent like oranges, then we would say I have 5 oranges, take away 3 oranges. What I have left is 2 oranges. And so that's how we would combine like terms then. What we need to know whenever we're adding and subtracting polynomials is that we're just basically combining like terms, kind of like what I did here in this example I just made up. The only other thing that we need to watch out for is whenever we're trying to take a polynomial and subtract a polynomial from it, okay? So if we have that type of situation, then we need to make sure that we distribute the understood -1 across all the terms that comes after the subtraction sign, so that we can make sure that we're subtracting every term of that particular polynomial from the one that comes before the subtraction sign. Okay, so let's move on, and now let's do some examples. So with our first example here, we just have 2 polynomial expressions here. This one is a polynomial expression that looks like a line. This one is one that looks like a quadratic. And so all we're basically doing is combining like terms together. So everything that has x's in it, as you see described here and here, will be combined together. Everything that has just numbers, as you see here and here, will be combined together. And of course, this is just the single term with x squared, so that won't have anything to combine with. So if I was to rewrite this, it would look like this: 3x squared minus 7x plus 7x plus 5 plus 5. And so basically I'm taking this and this and grouping it together, taking these two, grouping it together. And so now from here, you'll see that negative 7x plus 7x is just going to be 0 because negative 7 plus 7 is just 0. So that reduces to 0. That's why I have 0x here. And of course, 0 times anything is just 0. So really we could do this. And then of course, 0 plus anything is just that anything. So you see here, 5 plus 5 is just 10. This just ends up with 0. And then we have 3x squared there. So that's how I get the answer of 3x squared plus 10. For our second example, if you notice here we have subtraction. So 4 is technically a polynomial, but we're subtracting y minus 4 from that. So we know here we have to distribute our understood -1 that's here. And so I'm going to come here off to the side and sort of describe why that is. Now, whenever we talk about the definition of subtraction, we know that when we take something minus something else, that's the same as saying that something plus the negative of what comes after. And so this is a B, not a 6, just to make sure that that's clear. And here we also know that for any number or expression that is negative, so for instance, if I have a negative b here, I know that I can get that from multiplying -1 times a positive b, okay? So here this looks like -1 times a positive b. And so here, this is why I'm saying that whenever we have subtraction, everything that comes after it, it is like it's being multiplied by an understood -1, okay? So here, when I look at this, I'm actually looking at it this way. And so now when I multiply everything by -1 here, what I'm essentially doing is changing the sign or doing the opposite of what I see in both of these terms. So this is why when I multiply this to both terms, the understood -1 being multiplied by that turns a positive y into a negative y, and it turns a positive 4 into a -4. And then, of course, from there, we know 4 and -4 are like terms. And so 4 minus 4 is just 0, and y is all by itself. So 0 minus y just gives us -y. So that's the reason why this looks the way that it does. Okay. All right, let's move on to our next examples. All right, so now we have a quadratic expression, polynomial expression, and we have a linear expression being subtracted from it. So again, we need to take the understood -1, multiply by both terms, which just makes it the opposite of what it was, and then we combine like terms. So of course, 2x squared is all by itself. 3x and minus 8x are like terms. So 3x minus 8x is going to give you a -5x, because we know 3 minus 8 is the same as saying 8 minus 3, which is 5. But since the sign, the negative sign is on the higher number here, we know that that's negative. Or put another way, if we think of this in terms of money, we know that we have $3 that we got paid, but we have a bill that's $8. So we get $3, take away $8, we're short $5. And so that's why that would end up being that. So and of course, we see here that the -9 minus 2 ends up being 11. Because remember, subtraction, this is like plus a negative. So this is like we owe somebody $9 plus we owe somebody $2, which means that all together we owe, I guess, both people or institutions $11. And this ends up being our answer here. For example, D, we see that we need to distribute our 4 to both terms here, -6 to both terms here, -5 to both terms there. And so if we do that, that would give us 4x minus 12, because 4 times 3 is 12. -6 times 3 is 18. And then append the x squared. -6 times 4 is a -24. Multiply that times x. And a -6 times 5 is a -30. And then, of course, here we have the -5, and we're sort of translating it to be like this. So we have -5 times x is a -5x, and a -5 times a +8, which is a -40. And then from there, we combine like terms. So we see here that the -18x squared is all by itself, but we have 4x, -24x, and -5x all need to be combined together. So if we have 4 apples and then we take away 24 apples, that leaves us with -20 apples. But then we know we have this other -5 here. So -20 apples minus 5 more apples. So that means I take away 20 and then I owe someone else another 5 apples. Altogether, that's going to be 25 apples. And let me move this back. And let's get this going like that. Okay. So that's how those terms go together. And so now the negative 12 and the negative 30 go together, and that's a negative 42. And negative 42 minus 40 is 82. And so I'll write it out so that you can actually see it. So negative 12 minus 30 is a negative 42. And then negative 42 minus 40 is a negative 82. That's how we get this answer here. All right, so now what we'll do is work some of these out from scratch. And so here we see that since we just have addition, that we don't have to do any distributing. So we can just combine like terms here. So we know that we have x squared minus x squared. And then we have a negative 3x plus 5x. And then we just have minus 9 all by itself. And so x squared minus x squared, that cancels to 0. Negative 3x plus 5x is going to be the same thing as saying 5x minus 3x, which is just 2x. So this ends up being a plus 2x here. And then there's nothing to go with the negative 9, so we just bring that down. And so 0 plus 2x is just 2x minus 9. And here, 2x and 9 are unlike terms, so we can't combine those together. So that's where we have to stop. All right, moving on to the next example here. Again, we just have addition, so there's no need to distribute anything, but we do need to combine like terms. So we have the 2y squared and understood 1y squared that are together. We have the negative 3y and plus 4y that are together. And we have the negative 8 and the negative 1 that needs to go together. So 2y squared plus y squared goes together. Minus 3y plus 4y goes together. And negative 8 minus 1 goes together. So we have 2 yams plus 1 yam gives us 3 yams. And we owe somebody 3 apples, but we get paid 4. So once we give the 3 away that we need, we know we have 1 left. And then if we owe someone $8 and then owe someone else $1, we owe everyone $9. And so then, of course, here we see that all 3 of these terms are unlike terms because, of course, this just has y squared in it. This just has y, and that's just a number. So this is where we stop. For example, C, notice that we have subtraction here, so that means we have to distribute our understood negative 1 to all 3 terms here. So I'm going to rewrite this 2x minus 5 and then make all these terms the opposite of what they are. So a positive x squared becomes negative x squared. Negative 3x becomes a positive 3x, and a positive 2 becomes a negative 2. And so now from there, we need to group these according to the like terms that we have. Of course, you got 2x and 3x goes together. You have negative 5 and negative 2 goes together. And you have the negative x squared that's all by itself. So we normally write these in descending order, meaning going from highest exponent to lowest. So the negative x squared will come first. And then after that, all terms with x will come after that. And then we'll just do all terms with just numbers last. Of course, the negative x squared is just by itself. 2x plus 3x is 5x. And negative 5 minus 2 is a negative 7. Okay. And so I want to make sure that when you look at this, this negative x squared that you see there is interpreted this way. okay? There is a difference in between negative x squared like this and negative x quantity squared like that. So these two things are very different. This is interpreted as being a -1 times x squared. So whatever answer that we would get if we knew what x was would end up being a negative number. Whereas here, no matter what we had for x, we would end up getting a positive number for an answer there. So when you see this written this way, it's written to be understood to be like what I have here. All right, so now what we want to do is move on to multiplying polynomials. And so when we multiply polynomials, there are three ways that I at least know of for working these out. And so the most popular way is using the FOIL method. And the FOIL method is just a way of ordering how you multiply two binomials together. And it's called the first, outside, inside, and last. And I'll go over what that looks like here in just a second. Another method would just be the vertical method, or I like to call it the vertical stack method. And we do this, I like to use this method whenever I am multiplying polynomials that don't have the same number of terms in it. In particular, if I'm multiplying anything where I'm not multiplying two binomials together. So polynomial of 2 terms times a polynomial of 2 terms, that's normally used for the FOIL method. But vertical stack, let's say if I have a trinomial being multiplied by a binomial, then I may want to employ the vertical stack method. And so the box method is just another way of doing the multiplication whenever you have polynomials that you're multiplying that have an unlike number of terms, okay? So the FOIL method is the most popular method out of the three. And so like I've said before, this is best used whenever you're multiplying two binomials together. And we know that a binomial is a polynomial that has 2 terms. So the FOIL method in particular here just describes how we go about multiplying. And so we consider this the first terms when we multiply. We consider these the outer terms whenever we multiply. We consider these the inner terms whenever we multiply, and we consider this and this last one here the last term. Sorry, not that one. Yeah, did that incorrectly. We consider this one and this one the last. And so you can see how I've kind of ordered that all out to make it look like how it's supposed to. So I'll go ahead and erase this right quick so that you can see that stuff. But here you see how I have ax times cx is just going to be a times c times x, and x times x is x squared. So that's how we get the x squared from that. For the outer, which is going to be this term and this term, we have ax times d, and of course, since we don't know what ax or d is, we just put it all together, just say adx. The inner, which are these two terms, b times c times x, which is bcx, and then the last term, which is just b and d, we multiply that, and we just have bd. Now, in the example below, you actually see this at work here. 2x times 4x is going to give me 8x squared, and that's the first. The outer, which is 2x times 3, which is a positive 6x. The inner, -5 times 4x, which is a negative 20x. And the last, which is a -5 times a positive 3, which is a negative 15. And of course, you see that these two middle terms here are like terms because both of them have x's in it. So all we have to do is figure out what is the difference in between 6 and 20, and that is negative 14. And that's why you end up with a negative 14x for the middle term. And so that's how the FOIL method works. If we did the same problem, but we did it by using the vertical stack method, then you can see I just stacked one on top of the other here. And I'm going to do this a lot like how I would multiply, let's say 28 times 12, okay? So here I know if I do 28 times 12, I know 2 times 8 is 16, I would carry the 1. And then 2 times 2 is 4 plus 1, which would be 5. And then afterwards, we would put a 0 here because we know we're moving now to the 1. And then after that, we would say 1 times 8 is 8, and 1 times 2 is 2. And then after that, we add. Okay? We'll do this the same way. We'll do this problem the same way we did this. It's just that now we don't have to worry about carrying ones and all that stuff when the number's too big. So here, 3 times a negative 5 is negative 15. 3 times a positive 2x is positive 6x. And then we move down. So now since we need to go to this term, 4x, we put a plus 0 there. And now 4x times a negative 5 is a negative 20x. And 4x times 2x is a positive 8x squared. And then from that point, we just add. Negative 15 plus 0 is negative 15. 6x minus 20x is negative 14x. And 8x squared just by itself gives you 8x squared. So you see that that works the same way. In the next example, you see that now I have a binomial now being multiplied by a trinomial. And in this instance, I've used the vertical stack method to do it as well. And the negative 4 times negative 1 gives you a positive 4. Negative 4 times a positive 3x gives you a negative 12x. Negative 4 times a positive x squared gives you a negative 4x squared. And then, of course, we move over to 3x, put the plus 0 right here, and keep on multiplying like how we would there, and then just add. If you do not like this method, you can always do this in a way that we call, it's called convolution, but it's basically doing distributing. So here we could say 3x times x squared times 3x times 3x times 3x times a negative 1. And then we do the same thing over again with the negative 4. And if you do it that way, you'll still get the same answer. And so I'll go ahead and work this out so you can see what this looks like. So 3x times x squared is 3x cubed. 3x times 3x is plus 9x squared. And 3x times a negative 1 is a negative 3x. And so now we can do the same thing with the negative 4 that's here. So negative 4 times x squared is a negative 4x squared. Negative 4 times positive 3x is a negative 12x. And negative 4 times a negative 1 is a positive 4. And you see, if we add all that together, we should get the same exact thing as we got whenever we did the vertical stack method. So you could either do it this way or that way. So if you wanted to multiply things using the box method, then of course we set up these boxes and according to how many terms we have in each factor. So for here we have 2 binomials. So we have to set up a box that is 2 by 2. So we see here that the 4x plus 3 put up here, 2x minus 5 we put there. And so now all that we're doing is we see that 2x times 4x is going to give us 8x squared, and 2x times a positive 3 gives us 6x. Same thing, negative 5 times a positive 4x gives us a negative 20x, and a negative 5 times a positive 3 gives us a negative 15. So that's how we get this. And so now from here, we just add up diagonally. And so in the diagonals, you see what are like terms. So notice that 8x squared and negative 15 do not have any like terms, but negative 20x and positive 6x are like terms. So we can add those together. And when we add those together here, we get a negative 14x as a result. And we see that we get the same answer that we've gotten all these other times we did this. And so again, if we do the box method for a problem where we have, let's say, a binomial being multiplied by a trinomial, then we need to make a box that is either 2 by 3 or 3 by 2. And so I've made this with a box that is 2 rows by 3 columns, but we can also do this by 3 rows, 2 columns, and it'll work out the same way. So I'll actually just rework this in doing it with 3 rows and 2 columns so that you can see that. So let's see, draw this box here. Do that, and so this will be x squared, positive 3x minus 1, and this will be 3x minus 4. And so x squared times 3x will be 3x cubed. X squared times a negative 4 will be negative 4x squared. 3x times 3x is 9x squared. 3x times a negative 4 is negative 12x. Negative 1 times 3x is a negative 3x. And negative 1 times a negative 4 is a positive 4. And so now from here, if we look in our diagonals, you'll see that these are like terms, these are like terms. So the 3x squared is all by itself. 9x squared minus 4x squared gives you a positive 5x squared. Negative 3x minus 12x gives you a negative 15x. And the plus 4 is just by itself. And you see that we get the same thing. All right, so now what we'll do is actually use either the FOIL method, vertical stack method, or box method to be able to multiply these polynomials together. And so for A, since I have 2 binomials together, probably the easiest way to do this is to use the FOIL method. So we want to do the first terms first. So x times x is x squared. Outside, x times a negative 1 will be a negative x. Inside, 3 times x will be a plus 3x. And last will be 3 times a negative 1, which is a negative 3. And then, of course, from here, we know that negative x plus 3x is going to be a positive 2x. And so this is our result. For our next one, we have 2xy quantity squared. And so what this really means is 2x minus y times 2x minus y. So again, this is just an abbreviated form of this. So we could do the FOIL method here if we wanted as well. And so in doing that, first, 2x times 2x gives us 4x squared. Let's try to write that again, make it look a little better. And now we want to do the outside. So that would be that. And that would be 2x times a negative y, which would be a negative 2xy. The inside will be a negative y times 2x, which again would just be a negative 2xy. And then negative y times negative y is going to be a positive y squared, because a negative times a negative is a positive, and y times y is y squared. And so then from there, of course, the first term is unlike all the others. Negative 2xy minus 2xy will give you a negative 4xy. And then we have plus y squared. So that would be how we would multiply that together. All right, so for example C, I'm going to do the vertical stack method for this one. So to do that, I'm going to, I have here a trinomial being multiplied by a polynomial of 4 terms. And so anything after a polynomial that has 3 terms, a trinomial, we just call it a polynomial in general. So I'm going to write the one that has the most terms on top, and then write the x squared plus x plus 1 on bottom, and then just multiply. So 1 times 1 is a positive 1. 1 times 2x is a positive 2x. And of course, we know that 1 times anything is just itself, so we can just rewrite all that. We need to do plus 0 here to give the space, and then we start multiplying everything by x. So x times 1 is just x. X times 2x is going to be plus 2x squared. X times a negative 3x squared is going to be a negative 3x cubed. And x times x cubed is going to be x raised to the 4th. And then now we have to multiply everything by x squared. So again, we got plus 0 plus 0. And now we start with x squared. So x squared times 1 is going to give you plus x squared. X squared times 2 is going to give you plus 2x cubed. And x squared times 3x squared is going to give you a negative 3x to the 4th. And then x squared times x cubed is going to give you x raised to the 5th. And so you're going to add all this together. So 1 plus 0 plus 0 is just 1. 2x plus x, make that x. It's going to give you plus 3x. Here we have a negative 3 plus 2, which is a negative 1. And negative 1 plus 1 gives you 0. So this will end up being 0x squared, or just simply 0. Here we have 1x cubed minus 3x squared, or we can think about it simply as just 1 minus 3, which is a negative 2. And negative 2 plus 2 is 0. So when we add all this up, this will just be 0x cubed. Understood, 1x to the 4th minus 3x to the 4th will give us a negative 2x to the 4th. And then x to the 5th is all by itself, so we just write that. And so then our final answer just ends up being the following. All right, and so for our last example, I am going to do the box method for this one. And so here I'm going to make a box that will be a 2 by 3. So let's make it like this. 1. And so now this will be 3x minus 1. This will be a negative 2x squared minus x plus 3. And so 3x times negative 2x cubed is going to be a negative 6x cubed. Sorry, I said that wrong. 3x times a negative 2x squared is going to give you a negative 6x cubed. And then 3x times a negative x is going to give you a negative 3x squared. 3x times a positive 3 gives you a positive 9x. Negative 1 times a negative 2x squared gives you a positive 2x squared. Negative x times a negative negative 1 times a negative x gives you a positive x, and a negative 1 times a positive 3 gives you a negative 3. And so just like how we did before, we add everything in the diagonals. So you got diagonal here, got diagonal there. Negative 6x squared, that's all by itself. We have 2x squared minus 3x squared, which gives you a negative 1x squared, or just negative x squared. X plus 9x gives you a plus 10x, and then the negative 3 is by itself. And so this is how we take polynomials and add them, subtract them, and in this case of what we're doing, studying different methods of multiplying them together. So thank you so much for checking out this video. Hope to see you again. Take care.